Okay, please join me in welcoming Bill Oliva with the Wisconsin DOT. Bill's been very active in the partnership. If you're from the Midwest, you definitely already know him. If you're not, if you're from the West, then you're going to get a chance to get to know him right now. He's talking about a subject of bridge strengthening, which is not technically a preservation activity, but I feel like it's a very important one because it keeps good bridges in service. And so please join me in welcoming Bill.
Hi, and glad to be here to share this with you. I did share this previously with our Midwest partnership, and I hope you all find this interesting as well. I'm here to talk about our local bridge strengthening program, a pilot project that we did at Wisconsin DOT a couple years back. So we're going to talk about what drove our strengthening program, which was load postings on our local system, an overview of the strengthening program and posting removals, kind of the assessment of candidate bridges and the methods that we implemented in this program. So I think we've all got these in our states, load postings. In Wisconsin, we post single tonnage, but we know there's a lot of other combination type postings out there. What really kind of drove our interest in this concept came about from the 2017 SHV evaluation program that all of the DOTs had to address this new fleet of vehicles that Federal Highways mandated we consider in our posting inventories and impact on our bridges. Well, as a result of analyzing the SHVs for Wisconsin bridges, both state and local, on our state system, not a big impact. You know, we at the time only had a limited number of state posted bridges. We're talking on the order of like 20 bridges posted on the state system. Local system was a different thing. So when we went through the SHV inventory, there were some new postings on that bridge inventory. And you can see the pre-SHV analysis here and the distribution of types of postings that we had. So it did create the new postings, some lowered postings. As we went through that, you can see we had an increase of over 800 bridges on the local system that required postings. Shortly after there, we went through a process of examining some of the overly conservative or unnecessary postings, using different methods to look closely or reevaluate those bridges. It did bring down some of the number of postings, but we were still left with quite a few bridges posted on that local system. So in response to that, we asked ourselves, what we could do to lessen those postings, regardless if they're on the state system or the local systems. These postings would inhibit the flow of traffic, freight, school buses, things like that. Politicians and the general public weren't very concerned who owned the bridge, just that there was a bridge out there creating a problem. We did give it some thought, and from our rating experience, we realized that there were some key elements on these bridges that were controlling the postings. And we really asked the critical question, what could we do about this, in working with local owners? And that brought about the concept of our strengthening program. In the state of Wisconsin, we do have a local bridge replacement program, and it operates differently in different states. In Wisconsin, we're typically using 80% federal dollars, 20% local dollars to replace those bridges. And the vast majority of work in Wisconsin was replacement of bridges. There was some rehabilitation being done with those state, federal dollars, but a small percentage. In Wisconsin, based on our statutes, to be eligible for bridge replacement, you had to have a sufficiency rating lower than 50. To be eligible for rehabilitation dollars, if you were going to go that route, you had to be sufficiency rating less than 80. And we had, as you can see by the blue dots here, quite a range of load postings out there, and quite a range of sufficiency numbers associated with those posted bridges. So, the big problem, as we understood it there, were kind of like bridges that were posted but still in good condition, based off of the deck, super, or sub. And it was a shame to, if they were replaced prematurely. So what we kind of did was focus on this boxed area, which we felt represented good condition bridges with load postings. You'll notice that we've got postings in excess of legal load, 40 tons. And that's because in Wisconsin, we've got some statutory legal loads that are in excess of that 40 ton because of various industries, timber, dairy, and others. We've got quite a menagerie of legal loads in Wisconsin. But this boxed area was particularly interesting to us, and we thought there was something we could do in response to that. And again, it was being driven by that SHV analysis that brought to light a lot of these concerns. When we put those load postings out there, primarily for safety purposes, right, to protect the public, we're posting these bridges. But there's a lot of them that were out there because local owners wanted to protect their infrastructure from deterioration because of oversized loads going over them. Talked to our management about this, and they supported the idea. So we kind of created this pilot project with the concept of strengthening local bridges. And the concept behind this program was to work with the local owners to implement cost-effective, streamlined solutions to fix these bridges. What was really unique here is within our Bureau of Structures, where we have structural engineers, pretty much only or exclusively, we're going to ask them to do all of the engineering work to assess, identify, and detail repairs to these bridges. We also wanted the local units of governments where they were capable to do the work themselves. So county highway shops, with workers who might do some bridge type work, but also they might do roadway type work to actually implement these repairs. And we wanted to identify common solutions that could be used on multiple bridges. So we wanted scale of economy and efficiencies identified wherever possible. This is kind of doing business in a very different way in Wisconsin. So how do you get money to a local unit of government to fix their own bridge? We've got LET programs and all sorts of processes and systems set up to run things through a competitive process like that. But there are some tools that we had. We have this contract type called a local force account agreement, which we can exercise with local municipalities. Typically this might be for them to set up traffic control or something like that on a state system bridge, or to do something associated with a state project on the local system. But we were able to persuade people and utilize this type of an agreement to actually engage in contracts with local entities to fix their own bridges. The counties would be reimbursed directly by the state of Wisconsin, so these were dollars coming out of our bridge program. For this pilot program, 100% of the costs to the counties or the local units of governments would be fundable by the department. So we weren't asking the counties to put any money in on this pilot project. We wanted to see if we could actually do this, and if we could do it, what the benefits would be. So it had a limited scope of work, so we were staying off the approaches. We weren't fixing curves. We weren't doing anything with any of the safety features leading up to the bridge. This was about strengthening the bridge and removing the load posting. And as a result, it got us out of the realm of a lot of the environmental concerns that we might deal with typically. Also utilities, real estate, and things of that nature. So that really helps streamline the overall process. The posting removal process. So we wanted to target high-value bridges with remaining life in there, and we realized that every repair option wasn't feasible for each of the bridges. But we needed a way to screen the bridges. So in the lower left-hand corner, you can see the criteria that we used. So we wanted bridges that weren't in the program already for replacement. And we generally run a 6-year improvement program, so they couldn't be in there. They had to be posted for less than 40 tons. So if some municipality was posting them above 40 tons to protect them from the quarry down the street, or the timber industry or something like that, we weren't making them eligible for those. We wanted the NBIs of the deck, super, and sub to be at least 5, good condition bridge, so we didn't want to go out there and strengthen something that inherently would need to be replaced in a few years because of some other condition issue. And we wanted a significant ADT on the bridge. Here we have more than 100 or less than 100 with a significant detour route. So we wanted it to mean something to the users out there as far as removing impediments to travel. So based off of that screening, we had a first run through, and we came up with a number of bridge types that we could potentially strengthen. There were an awful lot of timber bridges in Wisconsin that fell into this criteria. Good number of steel girder bridges and concrete slab bridges also. And then a whole host of other less frequent structure types like trusses, deck girders. Our pre-stressed girder inventory for the local system was doing really well, so that generally wasn't a concern. Within our pilot project, we identified 16 bridges that were good candidates for these construction modifications. There were also an additional 14 bridges out there that we pulled into this pilot that we were going to use more complex analysis techniques to justify removal. We considered those part of this program because we were using very unstandard tools to do the analysis to get them justified for removal of posting. And we'll look a little bit closer at those in a bit. Let's focus on these ones with construction details first. So with regards to the timber structures out there, in Wisconsin we've got an awful lot of these spike laminated timber deck structures. And they have transverse post-tensioning ties in there and spreader beams on them. There are a lot of them out there that were posted, and we worked with industry and the Forest Products Laboratory and others to get some ideas on what we could do out there to retrofit this type of structure or address, the strength of them. What we came up with was a spreader deck for these types of bridges. Essentially what it was a transverse spreader deck, and it helped create a larger load distribution area that would provide more capacity for the overall superstructure. Concurrently, or I won't say concurrently, but right after this, we did some research. They did do some monitoring in the field. Iowa State University came out there as part of the Wisconsin Highway Research Project, which was recently published on our research page. And they did monitoring before and after these spreader decks, but they also looked at the other components. So I did want to point out to people of interest with the timber bridges that those transverse spreader beams are pretty important. It's not as much the number of them as the size of them. If you do have a lot of these timber bridges in your inventory, I would recommend looking up on the State of Wisconsin Highway Research Program, a recently published report that's got some neat findings. It also found that the distribution factors that are prescribed in the manual bridge evaluation are a little conservative based off of the findings of this study. So some good information there. But we did implement these spreader decks on a number of the bridges, and they performed quite well. And what was really cool about these was that the county workers could easily put these in. So, here's an example of one of the bridges where the county workers did the work. Within Wisconsin, one of the suppliers of this spreader deck and the actual timber superstructures is Wheeler Consolidated, and they worked closely with us as we were telling them what we had in mind. We worked back and forth. Our staff within the Bureau of Structures did the design work associated with these. The county supplied the workers, and Wheeler Consolidated provided the materials under contract with the county. So the counties would come out there and remove whatever overburdens over that superstructure and clean it. They would then put down these spreader decks, as you can see here, and it was pretty manageable to do with their staff, not a lot of special training, a little bit of guidance from the supplier of the timber superstructures. So you can see them spiking down those new spreader decks. They would then grout between the new spreader deck and the pre-existing deck. And there you can see the close to finished product. And then come back with, in many cases, an asphaltic overlay over the top of that. And the counties really loved them. They could do this work efficiently, effectively. They had the tools and the whereabouts to do all of this. So it was highly successful and very economical to do this. So it was a great lesson learned and a new tool in our toolbox, or the locals' toolboxes, as they go forward to manage their own bridge inventory. Not only did they do the spreader deck, but here's one where they did a superstructure replacement. And this was a concrete deck on steel girders. It was insufficient capacity as that. We went through and designed a whole new timber superstructure for that. But what was really neat here is the county was able to come in and do that work. And as you'll notice, what's really important is as they replaced that superstructure, they didn't have to get down into that stream, or they didn't disrupt much of the existing approach asphalt or roadway. So, as we went through this process, we're still subject to the same environmental laws as all transportation projects and agencies are. But we made a number of commitments to our Department of Natural Resources to streamline what was required for an environmental document. And we were doing that work, again, with structural engineers within our Bureau of Structures, not roadway designers, who do this day in and day out as part of the overall project. But we were asking our structural engineers to get involved and do this type of coordination. We made commitments to our DNR that we could do this type of work without adverse effect to the environment. And we did time and time again come through with that commitment. Also, timber slab reevaluations. Alex Pence of our Bureau of Structures in Wisconsin did identify some issues with a wet service factor within the evaluation code, and worked with a number of the AASHTO committees and Forest Products Laboratory to kind of build understanding and commitment to a revision or interpretation to that wet service factor for timber evaluation, which also resulted in providing more capacity and removing some of the postings in Wisconsin. And that, I think, is going to be updated in the code provisions for evaluating bridges. And on to other types of retrofits. We did do steel girder retrofits by bolting on additional steel section. Those were pretty easy, clean-cut type projects to do. You know, whether we were bolting on angles or plates, it was pretty easy to design and detail those and implement them in the field. This is another example where county highway personnel were retrofitting one of their bridges with steel, and another good example of, with their own means and methods, how they're able to control and minimize any impact to the environment. So they built their own working platform to stay out of the water, to be able to get underneath the bridge, drill and bolt and attach additional sections. You know, we were amazed, you know, again, they had no guidance from us on how to actually get out there and do the work. We certainly made it clear to them what they had to do, and we verified that they did it, but their means and methods were up to them. And you can see the workers, you know, down there doing the work, drilling and attaching these steel members. It really went well. We did a number of concrete slab retrofits. We did use additional steel reinforcement. We used FRP type, both fabric on the undersides, but also FRP dowel reinforcement in the top and the negative moment areas as well. Here you can see an example of FRP underneath, you know, the bridge in strips. Completed all of these in our pilot project. What was really wonderful about this was industry. You know, they stepped up to the plate with us, and they came out to county highway facilities to train the county highway personnel prior to them doing the work. So industry reps came out and really worked closely. And you can see here on the right, a little workshop where we had one of the suppliers come out and actually teach the highway staff, you know, the proper way to apply the FRP fabric. You know, that was really just wonderful. Because, you know, certainly they'd be able to implement it on this bridge, but now within that county's toolbox is another tool for them to use, hopefully on their bridges and with the support of a design. We also used steel plates to extend the negative continuity steel over piers. This is an example there. We'll kind of go quicker. So in Chippewa County, Wisconsin, they had this multiple span haunch slab. So this is a video of them doing some work. So essentially what they're doing with this, you know, H15 design era bridge is extending the continuity steel with these steel plates. And to do that, they had to mill off a certain amount of the bridge deck. You know, county crews doing this work. And then attach essentially additional reinforcement to extend that cutoff length. But to do that, you know, there were a number of steps they had to do in preparing the deck and using some new materials. And you can kind of see what's going on here. Yep. And they're using some of the Quick Bond product and had some support from the regional Quick Bond suppliers. So that was really cool. But time and time again, we were really impressed with the capabilities of the county crews to do a lot of different types of work actions on their own infrastructure. So kind of raised the bar on what we could expect. So those steel plates are going to be bolted down to that bridge deck. You know, they were making some leveling pads there. Drilling them in. They preloaded the structure before engaging those plates. As part of the design requirement. This is Alex Pence. He's crouching down, and Andrew Smith of our office. They're installing some strain gauges to measure and verify that these plates in fact engage and operate properly. So as they unload the structure, those plates should be engaging, and Andrew Smith is verifying that. So it's kind of great that we had that capability within our office to do that. Not many DOTs do have that. So after they attached those plates, the county crews came back and put their own overlay over the top using a vibra screed. So they're able to complete that really well, really pressing the limits of what county highway personnel have done in our state and will be able to do going forward. Aside from the construction details that we implemented in the field, we also did refined analysis, I believe 16 additional structures to remove the load postings, going beyond just the simple line girder models to three-dimensional models to better understand the load distribution paths and structure response to justify removing load postings as appropriate. Going forward, we still have a little bit of issue on the chart on the right shows, our back in February of 19, what we showed as far as calculated needs for load posting versus the actual signed bridges out there. So we have some municipalities that are still load posting their structures unnecessarily, and we work with them with outreach to try to persuade them to post to the actual capacities of the structures. There were a lot of benefits to the counties where we did this work. It's a very cost-effective method to help maintain bridges. These costs were way lower than what they would have been if we would have let them through our LET program. And we could clearly see that. So we were really happy about that. New challenging work for their crews. So what's really cool about that is, yes, they can do this work on their own infrastructure to manage it. Within the state of Wisconsin, these county highway groups also help maintain and do maintenance on the state system. So as we go forward, they can do more for themselves, but they can do more for us as well. So we're really happy about that. Learning opportunity, new methods and challenges can be applied to other projects and programs, as I just discussed. They can now also use these capabilities not only to do the county highway bridges, but the townships within those counties also could benefit from this. So a lot of options for the future. So going forward, what is shown in the map essentially are a whole bunch of potential candidates there. A lot of these are in the program for replacement, so there's no need to strengthen them. We'll just let time take the replacement path. But going forward, about 80% of these bridges that are posted are owned by the counties, so there'll be a lot of outreach, if we go forward. What challenge we really face is from the legislation standpoint or in statutes within the state of Wisconsin. We really push the limits on what we can do outside of our LET program, because of the political implications about contracting directly with the counties. We didn't burn any bridges with this one, but we did bump into a number of statutes that we could mitigate at the time with the status of a pilot program. But going forward in Wisconsin to implement this on a much larger scale, we're going to need to work with our legislature to make some changes to our state statutes. We're doing that outreach. Clearly our legislature is really interested in this. Our County Highway Association is very interested in this also. So we're crossing our fingers as we go forward into next budget cycles and hopefully see some changes that kind of codify this program within the state of Wisconsin. Huge thanks to Alex Pence of the Wisconsin DOT Bureau of Structures. He really took on a lot of this effort, but together we got this done. Any questions? What's the life of a spreader deck? Boy, that's a good question. I don't have a great answer to that. They look pretty robust to me. I would hope that it would last, 15, 20 years at least, but it might have the longevity as much as the parent deck below it. Any other questions? Nancy? As far as the postings are over conservative, or the actual, numerically, a good question. A good example might be with some of those timber bridges that rated low, but because of things like that wet service factor, they actually had a higher rating. Another good example, I have to struggle to put my finger on one, but there are a number of factors in there. Just the slab type structures. from the research that we recently completed, which was on timber bridges, but also has some implications to like slab-type superstructures, that the actual distribution of live load as monitored by the research is actually much better than the code provides for. That would be another example.
I think that was just a great example of a local agency and a state partnering together for each other's benefit.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.